So the deep western boundary current of the Southwest Pacific Basin is a deep ocean current that transports the cold and dense waters formed around Antarctica northwards into the western South Pacific and North Pacific Oceans. Here, I've used deep Argo floats profiling within the deep western boundary current as it flows along the western flank of the Kermadec Trench. These deep Argo floats measure temperature, salinity, and pressure between the sea surface down to as deep as 6,000 meters. Using these deep Argo measurements within the Kermadec Trench deep western boundary current, I found seasonal cycles in dynamic height, temperature, and salinity. Then by decomposing temperature into changes due to heave and changes due to spice, I found that these seasonal changes were predominantly due to heaving of the deep ocean. Now, changes in the ocean due to heave are often wind-driven. However, the seasonal wind regimes change over the latitude range of the Kermadec Trench. I therefore used the GLORIS eddy resolving ocean reanalysis, which was validated against these deep Argo observations to examine deep western boundary current seasonal cycles in both the northern and southern Kermadec Trench regions. So in the southern Kermadec Trench, there was no deep ocean seasonal cycle evident, as was expected given the transitional nature of the Ekman pumping seasonal anomalies here. However, a deep ocean seasonal cycle was evident in the northern Kermadec Trench. These seasonal changes in the northern Kermadec Trench are consistent with those expected if local Ekman pumping was driving deep ocean seasonal heaving. In addition, monthly anomalies of Ekman pumping and deep ocean dynamic height were significantly coherent and almost in phase at the annual period. These results indicate that seasonal heaving within the deep western boundary current in the northern Kermadec Trench is predominantly driven by local Ekman pumping seasonal anomalies. This wind-driven seasonal forcing suggests a pathway through which shifts in surface wind patterns are likely to influence the deep ocean on relatively short timescales. And finally, seasonal heaving within the deep western boundary current may produce corresponding seasonal changes in deep western boundary current transport through upward heaving or vortex stretching, causing enhanced equatorward flow in the deep western boundary current.